All right, so my name is Yuzhao, and I'm working with Chenqian and Yuzhao on the final project of deep learning for computer vision of Columbia University class of computer science 495. And our final project name is multi-label beverage packaging detection. So why do we want to do this? The main reason of this was because sales market consumes an enormous amount of beverage every day. Well, as it at the same moment, right, it yields an enormous amount of beverage packaging at the same time. So as a waste disposal site collect the waste from the public, the trash that include all kinds of waste is oftentimes mixed together, right? You can see all kinds of waste disposals mixed all together, all up, right? Transportation and waste management of such beverage products require identification of packaging materials, also categorization from the packaging outlooks, right? So while the mixed waste makes this process extremely hard, and the success of classification of waste package in the process of recycling can increase the efficiency of material redistribution and better assist waste management, such as material recycling and waste categorization, right? On the other hand, right, the beverage companies, they will be super duper interested in recycling their own products, which will make it easy to reuse the material made by themselves, right? So the process of categorizing both the label and the material is needed in the waste disposal market. So we can use computer vision technology to boost up this kind of process in the process, of waste identification and distribution process. And specific brands such as Coca-Cola or Sprite or other companies, right? They will be interested in this process of recycling waste disposals. And what kind of data do we need to use in this project? So at the very beginning, right, we figured out we probably need the data from the disposal site, which has gigantic amount of waste disposal data, right? But the thing is, the issue is it is very hard to collect data from them because we don't have access or APIs or build up API from the disposal site. They don't do such data collection job in their daily work. And the second thought, which became our final decision, right, is that we use the parse data from the internet. So we basically parse the beverage packaging data from the internet. So as you can see from the examples below, we have all kinds of data. We have all kinds of beverage packagings, including Coca-Cola, 7-Up, Fanta, and Sprite, etc. So we collect data from the internet and we manually delete some noise data or noise points from the data site so that we can use in the later machine learning model training process. And in this process, we are basically using the data. We're basically using two kinds of classification. One is the brands of the products, which is Coca-Cola, 7-Up, right? And the second classification will be the materials of the packaging. For instance, right, the can, aluminum, or the can, right, the plastic bottle, or basically, or simply just a glass bottle, right? So we are doing the pipeline. We're doing the parallel stuff right now. We're predicting two labels at the same time. And now let's have Chenqian introduce the following slides for us.
Yeah, so for the data collection method, we initially choose to use the Python web crawler to get all the images. And then we change to use the image download API since which has a much more efficient and clean way to collect all the data. And we mainly focused on the Google Image Download API and Bing Image Download APIs. And we found that the Google API was kind of buggy and slow and lack of maintenance. So we finally focus on the Bing Image Download API to collect all the data for all the 6 categories. And yeah, and next slide. For the data format, as we mentioned before, we have 3 beverage brands, and we have 2 material types. So we have a total 6 categories, and we use like 1,000 data points as for per categories. So for the training, validation, and testing ratio, we have like 70% of the data as training and 20% for validation and 10% for testing. And we also do some manually data cleaning to reduce the noise. And we separate the data into, as we said before, the training, validation, and test for the further processing. And yeah, for the multi-labels, we realize that if building a model that predicts the 6 categories simultaneously would yield a bad performance. So we finally decide to use 2 parallel models. And one is beverage brand prediction model, which we can predict the beverage brand of each beverage, like Coca-Cola and 7-Up, Fanta. And we have another packaging material prediction models that we can classify the can and bottles. So yeah, and we experiment on really some popular pre-trained CNN deep learning models, and that we basically replace the output layer with the fully connected layer that is consistent with our labels, and we retrain the pre-trained models, and that's the model performance for those models. And we also had 2 customized CNN models. For the CNN model, we just like stack 2 convolutional and max pooling layer to set the baseline for the whole project. And for the final result, we use a ensemble method, and we build a voting classifier that use our best model as estimator and make prediction based on majority voting, which gets the best accuracy. So yeah, as I said before, we have our best model, which is ModelNet V3 Small and AlexNet, and we use the best model as our estimators, and we set the number of estimators to 10. So in the end, our ensemble model have a prediction accuracy of 97% and 83 material classification. So yeah, and that's the prediction result. And then we will introduce the further conclusion by Yao, and yeah.
Okay, so based on our experiments, these pre-trained and MyCNN and the final ensemble model, we finally boost our model accuracy to 97% for the brand classification and around 8% accurate for the material classification problem. And we found that there is a gap between these two classification problem, and we dive into the reason why this happened. Okay, so from this slide, it is for the material classification problem, and you can see that there are some data that is incorrectly labeled by our crawler, which is a Bing API. And actually, our model are doing pretty on the actual classification problem according to human eyes. But we show some wrong predicted images here. Like the first one, there is a totally unrelated image. So there is no way that our model can get some feature from the picture can correctly predict it. So basically the accuracy is just a random guess. And from the second graph here, the green can, the true label our API gave is a bottle. And the result from our model is the prediction is a can. And from our human eyes, we can easily see that it is absolutely a can, not a bottle. So actually, our model predicts right this one, but since the noise from the data set itself, the data set thinks it predicts incorrectly. And it's almost the same situation for the bottom two pictures. And you can see here, this one though is not. It is even hard for human eyes to distinguish between the can and bottle. And on the right, it's just a toy car or something, and there's no way our model can predict image. And then I will talk about some future work we can do to improve our models or make some future work. And the first one is that deploy our model to the cloud service and enable the on-time prediction, which is according to our objective of this project, which is we will use it to help the markets to recycle the beverage packaging and to improve the performance of our model. We will have more high quality data and such as deleting some irrelevant data from the data set. And also, since we know in the real day life, there are a lot of different beverage brands out there, and we will maybe add more categories and waste type to our set and build a more complicated multiple classification models according to those data. And I think that is all for our final projects. Thank you.
Thank you.